example again. So, e.g., let us take y to be the cosine of 2x squared maybe plus 5x minus 3. And the question is, find the derivative of y with respect to x. This is a situation we can apply the chain rule because we can rewrite this as function of another function that is differentiable with respect to x. So if we do that now, you see how it comes out nicely. Look, let us set solution. Let us set, let's set u of x to be 2x squared plus 5x minus 3. This now means that y alone is equal to cosine of u. So we have simplified our function y just to the cos of u. Alright. We know how to differentiate cosine of function u. At least if you can't remember, you can resume the proof from the first principle and you obtain is using some trig identities that are familiar to us. So we have this. So here now, we have seen our u of x is. So if we want to apply the chain rule, apply the chain rule. We know the chain rule. It says that dy by dx is dy by du multiplied by du by dx. Please, the fact that I'm using u to substitute for this function all the time is not sacrosanct. That means you can use any other variable, provided you understand that you are trying to, reduce this expression to what is manageable using the chain rule. So do not get bothered that always I'm using u. You can use v, you can use p, something like that. Okay. So we have dy by du times du by dx. So we need to know who dy by du is. We also need to know who du dx is. And this is not challenging. Our dy by du is simply the derivative of cosine of u, which is minus sine u. And who is du with respect to x? So the derivative of u with respect to x is simply 4x only, then plus 5. You differentiate the constant to get 0. So this is our du dx. Now substituting these two here, you get that this is nothing but negative sine u multiplied by 4x plus 5, which we can take this here and then we have negative into 4x plus 5 multiplied by sine of u. I know who my u is. I put it back. This is 2x squared plus 5x minus 3. And this is the derivative of the function y with respect to x. So remember, this is a negative because of this. So this is how you can apply the chain rule to get the derivative of the function of another function. Alright. So, e.g., consider the function. This says let y be the square root of 6x squared plus 7x. And then the question is find the derivative of y with respect to x. We want to find the derivative of y with respect to x. Okay. Notice here that what we have is the square root of 6x squared plus 7x. We can rewrite this in this form. We can rewrite y as 6x squared plus 7x all raised to the power 1 over 2. And so it begins to look like the introduction I had at the beginning of the video, where I wrote y as u raised to the power n, or so on. So from here we can rewrite this. So if we set p of x to be 6x squared plus 7x, then to do this, we're going to have that y alone is p raised to the power 1 over 2. Yeah, so we have made this simplification, so this is equal to this. Okay. The next thing to do is to see that this is function of another function of x. So we apply the chain rule. So to apply the chain rule, we need to get the derivative of y with respect to p. I changed to p just to ensure that it does stick into your mind that always you must use u now. So dy by dp is nothing but 1 over 2 p raised to the power 1 over 2 minus 1, which will give me 1 over 2 p raised to the power minus 1 over 2. I can still simplify this and I get 1 over 2 multiplied by 1 divided by p raised to the power half, which is simply 1 over 2 p raised to the power half. This is our derivative with respect to p. Okay. Now, who is dp with respect to x? This is simple. This is nothing but 12x alone. You differentiate 7x, you get 7. We have done this many times, so I'm sure there's no need, spending time to explain how we got 12x and how we got 7 here. But if this will be confusing to you, the watcher, what I have done is to apply what I've said before. Ax raised to the power n, dy by dx is nax raised to the power n minus 1. So if you take a look at here, our 6 is n, our a is 6, our n is 2. So if we do that, this becomes 6 multiplied by 2, x raised to the power 2 minus 1, which is 12x alone. And that is how we got 12x here. The same thing goes for this. If you apply this, our n is 1, 1 minus 1 is 0, and then anything raised to the power 0 is 1. So, any number rather different from 0, you raise it to the power 0, you get 1. So this becomes 7. So the derivative of p with respect to x is exactly 12x plus 7. Alright. Now we invoke the chain rule. dy by dx is dy by dp multiplied by dp with respect to x. And this will give me, I simply put here, this is 1 over 2 p raised to the power half multiplied by 12x plus 7. And then if you do this very well, we're going to get 12x plus 7 divided by 2. We know who p is. It is this. So this is simply 6x squared plus 7x raised to the power. In fact, let me write this as square root. So this is the derivative of this function y with respect to x. It is 12x plus 7 divided by 2, the square root of 6x squared plus 7x. So this is how we can apply the chain rule anytime you have function of a function to get the derivative with respect to x or whatever variable you are interested in. Okay.